Hi everyone, we are from West Godavari Institute of Science and Engineering. We done a project called Analyzing Airline Delays Using Interactive Dashboards in Tableau under the domain of Data Analytics and Machine Learning, presented by GIRIPRASAD, SUVARNA, BHARATH, SATYA, KIRANKUMARI. Flight delays are a common issue affecting both passengers and airlines. To overcome this, we developed a model. The project aims to predict whether a flight will be delayed or on time. Our project helps the public improves travel experience, helps airlines to plan better, supports vulnerable passengers. And my project focuses on predicting flight delays and visualizing delay patterns using dashboards to assist in better decision making. Flight delays are a common problem and can affect passengers and airlines in many ways. By using past flight data like time, weather, and routes, the system learns patterns and helps predict if a future flight might be delayed. This can help airlines plan better and reduce inconvenience for travelers. Flight delays are a big problem that affect passengers, airlines, and airports. They can lead to wasting time, missed connections, and extra costs. This project tries to solve that problem by predicting whether a flight will be delayed or not using machine learning. Machine learning is a way for computers to learn from past data and make smart guesses about the future. This helps airlines plan better and avoid problems. In the existing system, flight delays are usually checked after they happen. Airlines and passengers only come to know about a delay when it's already too late to do much about it. There are no smart tools being used to predict delays in advance using past data. Also, most systems do not consider important factors like weather, traffic at the airport, or flight history to guess if a flight might be delayed. This means the current way of handling flight delays is not very efficient or helpful for passengers or airlines. The main drawback is data quality issues. The proposed system is a new and smart way to predict flight delays using machine learning. It learns from the past data and makes predictions about whether a future flight will be on time or delayed. This helps airlines plan better and avoid problems. Passengers get updates in advance, reduces the overall impact of delays. In short, it's smarter, faster, and more helpful way to deal with flight delays. The first phase, we plan how to build the system. In the second phase, we gathered flight related data from the past years and cleaned the data to remove errors and prepared it for analysis. In the third phase, we used the clean data to train a machine learning model, and the model learns to predict flight delays. In the fourth phase, we create a visual dashboard using Tableau to show the results in a user friendly way. In the fifth phase, we validated the model's accuracy by checking if the model works correctly using the test data. In the sixth phase, we monitor its performance and results in real time. In the seventh phase, we make sure it can handle more data or users in the future, and we keep the system updated. We have used some modules like Pandas, Scikit-learn, and XGBoost, Flask, NumPy, Matplotlib, or Seaborn, and Tableau to develop this project. The dataset was taken from the Kaggle website, and we performed some operations, clean and reprocessing. And we used Python language for developing, and we used Tableau for creating the dashboard user friendly. And this is the block diagram for our project, and this is the architecture diagram for our project. First of all, we took the historical flight data and we processed the data, and we applied some machine learning models like random forest, XGBoost, and support vector machine. and finally we delayed predictions, and finally we created dashboard in Tableau. So I would explain how I implemented this project. Here is how I implemented my project. I started by installing the required libraries such as pandas for data manipulation, scikit-learn for machine learning, and numpy for numerical operations. I also imported models like support vector classifier and logistic regression and metrics for model evaluation. I loaded the data file. This dataset contains the flight information used for training and testing my model. df.head function. I previewed the first few rows to understand the structure of the data. Type of df. I checked the type of the loaded data to ensure it is a pandas data frame or not. The dot shape function returns the number of rows and columns. This helped me to understand the size of the dataset. df.describe provides descriptive statistics for all numerical columns in the dataset. It gives you a summary of important values like count, mean, standard deviation, minimum 25%, 50%, 75%, and maximum. df.info gives a concise summary of the dataset structure, total number of entries, column names and their data types, number of null values in each column, and how much memory the dataset consumes. df.fill of 0. It is used to handle missing values in the dataset, replaces all the null values with 0. This is important because many machine learning algorithms cannot handle missing data. df is null dot sum function used to check for missing values in the dataset is null function for return true. For all null values, sum function adds up to the number of true values in each column. By just typing df, we display the entire data frame. I used this to visualize, inspect the data after cleaning steps like fill missing values. Here, I imported two important Python libraries for data visualization. Seaborn. It's built on top of the matplotlib and is used for making interactive and informative statistical graphs. Matplotlib allows creating various type of plots like bar charts, line charts, and scatter plots. I imported label encoder from sklearn.preprocessing. I created an object LU of label encoder, which I later used to encode call in my dataset. I applied label encoding to the origin column. I applied label encoder to the destination column, and I did reshape as well. I applied label encoder to the carrier column as well, and I reshaped the column as well to proper structure. I applied label encoder to the delayed column as well. Here I defined feature variable X and target variable Y for my machine learning models. By splitting the data, I can train a model. Creates a histogram of the delayed column to visualize the distributions of delayed versus non-delayed flights. On the x-axis number of data, on the y-axis the delayed. The same for the deep delay minutes also. It is also representing with the histogram. The title was the deep delay minutes and the x label is the delay and the y label is the number of data. By entering of the x, we are getting the we are print we are getting the count of each unique value in the target variable. I imported the necessary libraries, pandas for handling data, pickle to save the trained model, random forest classifier for the training the ML model, train test split, divide the dataset into the training and testing sets. By getting the R square square helps to how well the model fits the test data, and the mean square error, the average square difference between the predicted and actual values. We initialized the linear regression model as well. We used the pickle module to save the trained linear regression model, and I saved the XGBoost model using pickle just like I did with the linear regression model. Now we can run our project on the front end, which we created the web page called flight delay prediction. So this is the web page we created for predicting the flight details. So we need to enter some details like which is in the database, which is in the dataset, past dataset. So I gave here origin as 0 and destination as 20, carrier as 4, temperature as 30, and wind speed is 3. So now I will submit it. So I get the delay time 8.18 minutes. So if you want to predict another flight, just click on it. So again you can check here, or else you can view theory as well. So this is the model. Again, we had created a dashboard, Tableau dashboard for the user friendly. So this is our the Tableau dashboard. So we get the flight delay analysis over time, and here we will get the details by the origin and the destination, and here we get the top delayed airlines. Here we have the Misa Airlines INC, the most delayed one, and we have a filters here, so we can select according to our bookings. So by selecting here, you can experience here the interactive dashboard, and the delay category also is an filter. You can select here, and you got the here deep delay minutes, and here the percentage breakdown. So this is our project which helps the customers for the better satisfaction. In the future scope, we can integrate with real-time data sources like live integration with the air traffic control system, airline database to provide real-time delay predictions. And we can have the mobile dashboard also, developing a mobile-friendly Tableau dashboards to allow passengers and airline staff to monitor delay and predictions on the go. And we have a wider geographic coverage as well, scaling the model to include international flight data, enabling global delay prediction and across multiple region and airlines. This project gives the effectiveness of ML models, random forest, XGBoost, and SVM in predicting airlines delays using historical flight data. By analyzing critical factors like weather conditions, airplane performance, and airport congestion, this system achieves reliable prediction accuracy and supports proactive planning. The integration of interactive Tableau dashboards enhance the usability of these insights by enabling dynamic data exploration, filtering, and visualization for stakeholders. And visualization offers a powerful tool for improving decision making, enhancing operational efficiency, and minimizing travel disruptions for both passengers and the aviation industry. Thank you.